Hey guys, it's Black and Purple Ministry, and what we're going to try and do is we're going to explain calculating limits without a graph. So recently, in the last few pages, we've been doing a lot about limits, and what we're going to do is try to find the limits when you don't have a graph. But here's the algebra version. So here it is, the property of limits. Let k be a constant where the limit of f of x when x reaches to c is the letter L, and the limit of g of x is going to equal m when x reaches to c. Emphasize where m and L exist. So if both of these functions, which will become limits, exist, then there are 4 different rules that are going to help us out when solving the different functions or solving the different limits. So here's the first one. If you have existing the limit of one function with the limit of another and they're added or subtracted, you can literally have that limit sign, this thing right here, and then you can put it here and here as 2 separate things, but you just reorganize the statement. The same thing goes with here, where if you have one that exists, that f of x and g of x, and you multiply them out together, you can literally do the same thing and separate the two, but in a different way. Over here, it also works when you're dividing, where if these two exist and are true, then this can turn into that, and that independently. But here's the thing. When you divide, the limit cannot be equal to 0, which means the bottom one cannot equal to 0. And for D, this is going to be another way to see it here. The limit of k, where x goes to c, it goes to k times the limit x over c. So you kind of reverse it, where you put one for the other, but still the same thing. So the goal of this calculus video is to tell you not on what the correct answer is, but to how to get the correct answer. So right over here is we actually did a problem in class. So here's what happens. Here's the limit of the function of x, where x goes up to 1, which is equal to 2. But the question is, how did we get to 2? Or if that's equal to 2, then find the limit of this giant thing right here. So, what can we do? Well, since we're dividing right here, we can use the dividing tool right up there and turn that equation down to here. So there's one thing that's being limited and another thing that's being limited for this one right here and for that one right there. The amazing thing that you can do is you can transform this into something else. So we transform to the bottom one and insert the number 1 into here and here, because 1 exists as a limit. But we also transformed that 5 because it's a 0 slope. When you have x to 1, it's going to equal 5. A 0 slope. So we have, when you plug everything in, 1 to the power of 3 plus 1 to the power of 2 is going to equal 2. And that is going to be our correct answer, is 2. So when you're trying to find the limits and trying to find it with these algebraic expressions, depending on what it is, you can use these tools, A, B, C, and D. And the crazy part is, you can only do that if exists a function that actually works, where you can't plug in to the equation if it's equal to 0 or it's false. Let's try another one. Well, actually, it wasn't the correct answer. That was part of the problem. Right over here, we can also plug in 1 for this one, and then 2 for that one, because we can, x goes to 1, plug that into there, plug the 2 into there, minus 5. So our actual answer is negative 3 over 4. So here's the remarks. When doing the steps, the bottom one, and you can plug in the numbers if the p of x is a polynomial, and the limit of the p of x, when you plug it in, happens when the x reaches the c. And number 2, the p of x divided by the f of x has to be a rational function, where the bottom denominator cannot be equal to 0. Let's try this one. So right over here is another scenario. We have find the limit where x is going to reach to the number 1. You have x squared minus 4 and x minus 2. Then you can transform that to x minus 2, x plus 2, x minus 2. But here's the thing. These right here create a hole. But in the limits, we don't care about holes, because all we care about is the direction and where it's located. Basically, you can have a hole in here and a line right there, while even though they're not exactly the same thing, to limits, they're technically the same thing. So since the x minus 2 and the x minus 2 is going to cancel out, we can move the limit x over to 1, x plus 2. Since 1 exists, we can put it into that x, and 1 plus 2 is 3. And here's the final part. Find the limit when x equals to 0, but here's the thing. We can not do this. We can't put it to 0 because it's not going to work, because d and e does not exist. So what we did over here is we multiplied both sides by x into here and into here. And then the limit is going to be, this is going to be disappeared. 0 is going to plug into the bottom right here. 1 divided by 1 plus 0 is 1. So as a summary for this video, here are some examples that you can take a look at. Here's some examples of when you can do it. You can plug it in, same with here, but not with 0. But then you can also check out the remarks to clarify the work you got. So yeah, thank you for watching this video on the calculating the limits. I hope this video has helped you out very much, and thank you for watching a Black and Purple Math and Ministry. Like and subscribe. Yeah!